Yeah, good evening, friends, and welcome to interview preparation session. So this is a continuation from tomorrow. Tomorrow, yeah, friends. So yeah, actually, we were going through statistics. So we had discussed three questions on statistics, central limit theorem, what is normality, and what are the assumptions, and what is hypothesis testing. Okay. Next, a question we'll be taking is what are outliers? So if you know the answer, you can just put your answers in the chat box. Okay, this outliers, they can be defined as the points, the data points in a data set, uh, the points which varies largely in comparison to others. Okay, so they are at the extreme ends. If you can see a box plot, you'll find them at the extreme ends. So they are having extreme values. Okay, so the data points which varies largely in comparison to the other data points, they are known as outliers. And these outliers, they may decrease the accuracy as well as the efficiency of a model. Therefore, it is crucial to remove this outliers from the data set. Okay. So coming to the next question, how to screen outliers, or how can you find the outliers? Basically, what is it is. So how to screen for outliers in a data set. So how to screen for outliers in a data set. Yeah, Venki, above and below the IQR. Yeah. Yeah, Venki, using box plot, that is, yeah, that is one method. Okay, so there are many methods, and out of which two of the main methods will be discussing it. One is z-score method. Okay, the z-score method. So in this method, okay, first we find the z-score. So how can we find the z-score? The z-score is nothing but it is the standard. So first of all, you must be sure that it is a normal distribution. Okay, first the distribution should be normal. Thereafter, we can calculate the z-score from this normal distribution. The z-score is 3 into standard deviation. Okay, so after finding this z-score, okay, the data points which will be outside of range will be the outliers. Okay, so if the z-score is somehow negative, then the data point will be below average or mean. If the z-score is close to 0, then the data point is close to average. And if the z-score is above or below 3, okay, if the value of z-score is above or below 3, then it is considered as an outlier. Okay, so 3 into standard deviation will be the z-score, and if the z-score is above or below 3, it is an outlier. If it is close to 0, it is you can say close to mean, and if it is negative, it is below the mean point. Okay, and the second method is IQR method, which we know box plot method uses this. So these two methods are used to screen outliers. Now coming to the next question, what are inliers? And now we discussed about outliers. Now question is, what are inliers? Okay, so inlier is a data point present in a data set which lies in the same level as others, means it lies in between the IQR range. Okay, but it is an error point. Okay, it is usually an error point, and if it is removed, the accuracy increases. Okay, but unlike outliers, inliers are very hard to find. Okay, so inliers are those points which lie in the data set and usually are an error, Okay, and if these errors are removed, the model accuracy increases. Okay, now coming to the next question. What are the properties of normal distribution? What are the properties of normal distribution? So here, a normal distribution means this bell curve. Okay. So what are the properties of a normally distributed this bell curve? Yeah, Venki, correct. So this mean equals to median equals to mode is, we can say, central tendency. Okay, this is the central tendency property. Central tendency, which means mean is equals to median is equals to mode. Then yeah, total probability is one, correct. Total probability is one, and range is minus infinity to plus infinity is also correct. Minus infinity to plus infinity. Apart from this, yeah, one element probability is zero. It is also. Apart from this, we are having symmetric. It is symmetrical. About mean, okay, then it is having only one mode or unimodal. Okay, so unimodal means just this one curve only will be there. If we are having a bimodal curve, bimodal will be having two modes. So basically two peak points will be there. Okay, trimodal will having three curves like this. Okay, So here normal distribution will have only one mode, unimode. Okay, coming to the next question. Now, next question is, what is p-value? What is p-value? Okay, so the p-value in statistics, okay, is calculated during hypothesis testing. Okay, and what is this? It is a number that indicates the likelihood of a data occurring by random chance. Okay, it is the likelihood of a data point occurring by random, occurring by a random chance. Okay, so we can also say this p-value is the probability of obtaining result as least as extreme as the observed results of a hypothesis testing. Okay, now coming to the next, what is alpha value? Alpha, okay, let me just write out. What is alpha value? Okay, so this alpha value, or it is also known as significance level. Okay, so it is the probability of rejecting the null hypothesis whenever this probability is true. Whenever it is true, it will reject the null hypothesis. Okay, for example, we can take a significance level of 0.05, which indicates 5% risk of uh, you know concluding that a difference exists when there is no actual difference. Okay, so if we consider a significance level of 0.05, it indicates that 5% risk of concluding that a difference exists when there is no actual difference. So it shows that 5% of error can occur. Basically, if you simplify it, you can say 5% of error is there. Now, coming to the next question. Yeah. What is a type 1 and type 2 error? What is a type 1 and type 2 error? In statistics, okay? So these are related to null hypothesis only. Yeah, so type 1 error. Okay, type 1 error. So type 1 error is the error in hypothesis testing. Okay, when the null hypothesis is error, when null hypothesis is rejected. Okay, type 1 error occurs when the null hypothesis is rejected, even when it is true. Even when it is true. Okay, then we are having type 2 error. Okay, these are the error in hypothesis testing. Okay, when null hypothesis fails to get rejected even when it is false. So when let me just do this. Okay, when null hypothesis fails to get rejected even when it is false. Okay, so there are terminologies related to this. Okay, this type 1 error is also known as false positive. Okay, these are also false positive, and this error are also known as false negative. Sorry, false negative. Okay, coming to the next question. Next question is when to use a z-test or a t-test. Okay, when to use a z-test or a t-test. So what are the criteria for doing a z-test and a t-test? Okay, so this z-test is used for hypothesis testing in statistics when the when we are having a normal distribution and it is used to determine the variance in a population. Okay, so this z-test is used whenever we are having a sample size of greater, means when the sample size is large. So large sample size is generally considered to be greater than 30. Okay, now this t-test. Okay, this t-test is used, or we can also call this t-distribution test. Okay, it is used when this is also used to determine the population variance, but this is done when we have a small sample size. Okay, so small sample size, here we can consider a sample lower than 30. Okay, so let me just write determine determine population variance when this n is sample size greater than 30. Same thing here. But it is just less than 30. Okay, now another question. So what criteria what criteria must be met for central limit theorem? So what criteria must be met for central limit theorem to hold? Okay, so what are the criteria for central limit theorem? Okay, so there are basically three criteria which must be matched. Okay, for central limit theorem to hold. First one is it the sample must be random, or you can say it the sample must be randomly sampled from the population. So I'm just writing sampling random sampling must be done. Okay, then second point is this these sample values. Okay, sample values must be independent of each other. And third, the sample size should be greater than 30, or we must have enough larger sample size. Sample size must be greater than 30. Okay, these three conditions should be followed if we want the central limit theorem to hold. Okay, then coming to the next one. Okay, so let us take this. What is descriptive statistics? What is descriptive statistics? Okay, so this descriptive statistics can be uh, they can be a summary of a you can say summary of the basic characteristics of a data set. Okay, so what can we know from this? So it is the basic characteristics of a data set. Basically, summary of basic characteristics of a data set. Okay, so in this, what do we see in descriptive statistics? So three things we see: distribution. Okay, then we see variability, and third we see central tendency. Okay, so what are these? So distribution, you can say frequency of responses, and central tendency, measure of the average of each responses, and variability shows the dispersion in the uh, of the data points basically. Okay, okay, so coming to the next question. What is standard deviation? Okay, I think we'll stop with the statistics question here. We'll move to algorithms. So we'll take this last question. What is standard deviation? Okay, so the standard deviation gives us the measure of variation of dispersion in of the values in a data set. Okay, so how the means how the values are dispersed in a data set, it gives us that measure. So you can, if you can simplify it, we can say it represents the differences of each observation or data point from the mean. So the formula for standard deviation is, if I can write it, standard deviation is like square root of x as the data point minus mu is our mean. Okay, x minus mu whole square divided by n, which is the sample size. Okay, this is the formula for standard deviation. Okay, so now let us move to some algorithm questions. Okay, so let's take the question from algorithm. So we already discussed type of learning, which is supervised, unsupervised, and reinforcement learning. So we'll start with the supervised. So is what is linear regression? So what is linear regression? Yeah, so this linear regression is a supervised machine learning algorithm in supervised machine learning algorithm, which gives us the relationship between one or more uh, you can say independent variable with one variable which is dependent on this. So this one variable which is dependent on these variables is known as the outcome variable, and all these variables which are independent of each other, okay, these are all input variables. So this linear regression, you can say it is used to quantify the, or you can say model the relationship between various predictor variables like you can say age, gender, height with one of the outcome variables. Okay, so next question, Yeah, another thing. So as this is regression, okay, the outcome variables will be continuous, which we already discussed 2 days back. So what are the assumptions for linear regression? So what are the assumptions that is required to be made for linear regression to occur? Means we can do linear regression if these assumptions are true only. So what are these assumptions? Okay, so let me just write here. Suppose X is input variable, input, or you can say predictor, okay, and they're independent. And this Y we can call it as output or even outcome, and these are dependent variables. Okay, so let me tell you the assumptions that are required for a linear regression. So first assumption is that there is a linear relationship between this dependent variable and the independent variable. Okay, that is one of the assumptions. Then there is another thing, that these all independent variables are independent of each other, or this predictor variables are independent of each other, which we already discussed. And also the errors, okay, the errors are normally distributed, and the errors do not have any correlation between them. Okay, that is also a assumption. And yeah, so this no correlation between the errors, this is also known as autocorrelation. And I told you now there is no correlation between the predictor variables. So if there is a you can say correlation between them, then the problem is known as multicollinearity problem. Okay. So if we are having a relation, means a relation between the predictor variables, any of the variables, predictor variables are dependent on each other, then it a multicollinearity problem arises. Okay. And if we are having some errors, and if they are having some correlation between them, okay, so these errors are should be normally distributed with no correlation between them. But if there is a correlation, this relation is this error or this problem is known as autocorrelation problem. Okay, then the variation in the outcome or response variable, okay, is same for all the values. Okay, the variation in outcome or response variable is same for all the values of predictor variables. Okay, so linear relation between predictor and outcome. Okay, predictor variables are independent of each other. Third, we are having errors are normally distributed and no correlation exists between them. Last is variance. So variance of outcome variables is same for all predictor variables. So coming to the next one, what is logistic regression? What is logistic regression? So as we know, this regression comes under regression in supervised learning. Okay, this regression comes under regression in supervised learning. Logistic regression, on the other hand, comes under classification. Okay, this is a classification problem under supervised learning. So what is this? What is this logistic regression? Okay, I think this will be our last question. So what is this logistic regression? Okay, so this logistic regression is a classification, uh, we can say supervised learning technique, which comes under classification. Okay, in this, our outcome variable, okay, our outcome variable, or we can say the dependent variable, is in binary form. So basically, two class, it should be, the output should be having only two classes. Okay, so if we take an example here, we can say whether it will rain or not. Suppose it will rain or not. So that is a logistic, means we can say this binary problem, whether it will rain on or not. And if we are trying to find this out on the basis of suppose temperature, humidity, wind, okay, all those requirements by which we can know where it will rain. Okay, so that we can call it as a logistic regression problem, because from these different variables we are trying to detect whether it will rain or not. So that is a logistic regression problem. Okay, so yeah friends, with this we'll just close our session here, and tomorrow we'll be seeing some of other algorithms, and also we'll be moving towards deep learning. So some questions from deep learning we'll also see tomorrow. Yeah, so thank you friends, and have a good day.